Hi, and welcome to the AWS Developers Podcast. I'm Romain Jordan, and today I'm sitting with Chris Weichel. He's the CTO of Ona, formerly known as Gitpod. Gitpod was this cloud developer environment. I've been using it for many of my projects. And since they rebranded, they have been talking about software development in the agentic space, and most recently about background agents. So I wanted to sit down with Chris to talk about background agents, better understand what they are. It's amazing to see how people are already living in the future. So I hope that you will enjoy the show. And if that's the case, feel free to share it with your friends and colleagues and leave us a nice review. Thank you. Hey, Chris, welcome to the AWS Developers Podcast. How are you?
Good. Thank you so much for having me.
Yo, thank you. Thank you for joining me. I'm really excited to have that conversation with you. I've been a big fan of Gitpod for a long time, so I've been using it for most of my personal projects. So really, happy to have that conversation with you today, and also understand what's going on, and because at some point you changed name, so wanted to also understand that, and you have expanded your focus from just cloud desktop to cloud developer environments rather to more agentic software development. So really keen to understand all of that and getting to know you better as well. So let's start with this. Could you start with an introduction?
Sure thing. So my name is Chris. I'm the CTO and co-founder at Ona. I have a background in engineering. I've been doing human-computer interaction in a former life. I built IoT devices, invented programming languages. I've been around the block a couple of times. A strong background in developer tooling, and that really also sets the scene for what Ona is and what Gitpod was. So
Okay.
very happy to get into that.
Yeah, perfect. Sounds good. Right. Perfect. So, yeah, let's talk about that. Let's talk about how you move from cloud development environment to background agents. That's the new thing that we see on our website. So, can you
Yeah.
tell us more about that?
Absolutely. So let's start with cloud development environments and where this has come from very originally. So the whole thing started because we noticed way back, a few years back, that PR reviews, manual at the time, were quite a bit of a nuisance. You had to essentially destroy your local Git state in order to review someone else's work. And you maybe were in the middle of some debugging session, had some local state that you now need to do away in order to review someone else's code. And even then, we had workarounds with like different directories where you held different versions of your code base. But what it led to is most reviews being looks good to me style reviews, right? Like you wouldn't actually look at the code. And the reason I dwell on that, even though that's many years ago, is that today we have these exact same problems again, which is, very funny. From that, we very quickly realized that the actual challenge is automating the development environment. So making sure that you can not only parallelize the code, have multiple instances of that, but you can have multiple instances of a development environment. Specifically because development environments aren't a static thing. It's not like you set them up once and then you're done for all eternity. As we all know, there's a lot of effort that goes into setting them up and maintaining them over time, much like any piece of software. They rot if they're not taken care of. So we've invested a lot in automating the setup, and it goes beyond automating the obvious things, right? Like when you think of development environment, the thing everyone thinks about first is tools. I need the right versions of this and that. But it's not just tools. It's also, I need secrets. I need access to third-party services. Maybe I need the RDS I need to connect to or what have you. I need packages and I need them in the right version. I need them at the right time. And if I do a git checkout on main, I'm 100 commits behind. Chances are I now need to also run, yarn or PNPM or whatever the cool kids use these days to download the internet again. So there's a lot that needs to happen before I can actually be productive and write code, especially on large code bases. So once you move sort of beyond the simple weekend projects and you move into real world code bases, you're either facing large monorepos, multi-gigabyte Java applications where, a simple Maven run will take an hour. Or you're looking at wild sprawl of microservices that really are distributed monoliths because we gave up on architecture at some point down the road. And so you have to bring all that into a development environment. That's really what we've been honing for many, many years. And that's what Gitpod really drove. So Gitpod, formerly known as Ona, and we'll talk about the name change, but that's what we built for a long time at Gitpod. And around 23, with the advent of essentially AI-based autocomplete, your Copilot and what have you,
Yes. Yeah.
it was clear to see where this would go. You would put one and one together. The moment you take the tab out of the equation, it became clear how this completion would happen automatically, what we now call agents. And sort of towards the as we were just at the cusp of Claude Code, which for many of us really was the, I think, thing that flipped the switch. We're like, okay, there's something here. Just before that, we started looking at the platform we had built and realized that what is very, very useful for humans, the automation of dev environments, is existential for agents. Because the moment you have something that can automatically write code for you, the thing that's becoming expensive is the human attention required to oversee this process. And if there's a one-to-one mapping, if I have to go and sit there and watch paint dry or watch an agent do its thing, my time is still very expensive, right? So
Yes.
you need to be able to do this in parallel. And the only way you can do this in parallel is much like we paralyze humans, by having multiple development environments. What's surprising to me, I'll say this, is the diffusion of that insight has taken longer than we expected. We're still faffing around with work trees, It's not, we haven't fully embraced this yet,
No, indeed.
but we are getting there. And so this is how we got from, we think of this as 3 stages. First stage, better autocomplete. A lot of enterprises are still there. It's easy to, especially if you're on the frontier, it's very easy to forget the long tail of diffusion. But a lot of organizations are just now rolling out Copilot. It's bewildering. Then the second step is agents, and a plurality of agents. We wrote about this at the beginning of 25, and we called it the software conductor. So the change of moving from an engineer to someone who now leads a team of agents, essentially. And we're now moving into the third stage, which is background agents, where instead of a human giving the input to, you now need to go and do this, and then you have some automated process, some agent that does it, you have essentially a form of factory. You have multiple machines that automatically pick up work and then go and execute on that. And you end up, I don't think I'd love to talk about dark factories at some point because this is
Yeah. I
topic.
was going to ask about that.
But in the first go, in this stage 3, you have multiple processes that anchor and interact with each other in order to drive a change end to end or to maintain software end to end. We have some very concrete examples of that. And in order to do that, you definitely need a plurality of development environments. There's no way you can do this on your laptop. Like, what factory would that be that stopped working if I closed my laptop, right?
Yeah,
And so
totally.
that's the journey in a nutshell. This is how we went from automating development environments to background agents, is through evolution and through seeing, what this technology would do and how it would need to be applied.
Good. Okay. So yeah, you have your cloud development environment. And by the way, it's not just cloud. You could also run that on-prem. I used to have my Gitpod on my Mac Mini as well. I could connect that remotely, super powerful. And then EC2, and so you can deploy that everywhere. And now we have this new era of background agents. But yeah, let's talk more about the second phase that you described. What I call orchestrator, the human as an orchestrator. I don't see a lot of engineers doing that. I mean, outside of Silicon Valley, of course. Still very well connected with my friends in Silicon Valley, and clearly that has been something that everyone has been working on for a while. And OpenClaw made it a bit more, visible to the rest of the world. But but still, people are still figuring out how to deal with those agents, and everyone is trying to customize, their agents and giving them specific powers and so on. Um, and what I think is quite difficult for many of us is the fact that yeah, you orchestrate across multiple, agent, and it's quite difficult to. I mean, you make sure that everyone is aligned, is doing their work, but it's a lot of things to review. And now, moving to the background agent, where it's as you said, a factory that is operating kind of by itself in the outside of your computer in the cloud or wherever, and that's very interesting. At the same time, I mean, it raises a lot of questions about how do we maintain and manage that? How do we make sure that the factory is not going to build something weird that we have no control of? Because even today, I mean, people are struggling to own the code that has been built by the agents. I know as an orchestrator. So I'd love to your perspective on this, and whether you have built some guardrails around that.
Yeah. If we look at the SDLC in a very simplified form: plan, implement, deploy, operate, and review. Sorry, plan, implement, review. Very important piece. Deploy, operate. What we see is that we've drastically accelerated the implement phase. Right, the thing that previously was the most expensive one, arguably, we've now accelerated like no time before. And like any production process, the moment you accelerate an individual step, you need to make sure you accelerate the others too. It's a max flow problem, right?
Yes.
And
Yeah, the bottleneck is going to move down the line for sure.
exactly. And that's exactly what we're seeing now, is where the bottleneck is moving towards review. It's the
Yeah.
clearest thing that everyone runs into. What Before we go there, I want to take a step back. You said something that not too many people are doing the multi-agent thing yet, and I find this observation very interesting. And the old addendum of the future's already here; it's just not evenly distributed, is more true than it's ever been.
Oh yeah.
And part of the appeal of ONA is the control that a platform can provide in order to make this happen. So one adoption challenge that we see within organizations, especially regulated industries and large enterprises, is that there is essentially fear around how can we give an agent enough autonomy in order to run in the background. So part of the appeal of better autocomplete is that it very directly holds a human in the loop. It's still the human writing code. The step beyond that, manual approval, where an agent asks you every 5 seconds, "Hey, can I do this?" Um, might look sensible, but there is plenty of studies that show that there is a vigilance problem. Your attention wanes off very quickly, and you'll be like, "Yeah, whatever, just go and do the thing."
Yeah. Just yes, yes, yes.
Exactly. That doesn't work. So what we do see with or especially saw us in the beginning of the year with a lot of our customers, was that they used the security that remote development environments provided in order to run agents. So the increase in autonomy and security that goes with it, that's needed to effectively deploy agents, can be created with isolated development environments.
Yeah, because basically you can't really rely on some of the rules that you expect the agents to follow. You really want to constrain the agent in a space that has been given the right amount of control and right amount of access. So it's not going to do anything that goes beyond what you expect it to do. So it's not going to change anything in production, for example, or the scheme of your database, whether and you didn't ask for it, and then everything is broken. So basically, with the environment that you are giving, you are um, restraining the agents to operate in a certain area.
Correct. It also doesn't have access to your email and to your
Yeah.
calendar and to your vacation photos and whatnot. So just by not running it on your laptop, that already is a massive, massive improvement. And then running it in an environment that gives you precise control over what the agent has access to and what it doesn't, goes the extra mile. So that lets you
Right.
run agents.
Yes.
Now you're producing code like you've never done before. You're moving fast. Doesn't mean you have velocity, by the way. Just because you're fast doesn't mean you're moving in the right direction. But then you see all of a sudden your pull requests going through the roof. So for ourselves, when we started adopting, well, our own agent, as a team of, at the time, about 20 engineers, all of a sudden we saw ourselves confronted with 450 open PRs. What do you do about that? And especially when you look at incentives and human behavior, it is so much more pleasing to produce a change than it is to review a change, right?
Yeah.
So this promise of we'll now be empowered to do the creative thing really has turned into we're now factory work, like assembly line workers who need to review masses of PRs, most of which, if people like, especially in the early days, not so much true anymore, but in the early days, it was just slop. It was,
The quality was bad.
I was going to use expletives, but it was not pleasant, right? So how do you deal with that? And what we have found is that at this point, automated code review is actually a meaningful way to tackle this. So that too has undergone several evolutions. In the beginning, in the early days, like sort of mid 25, I would say, automated code review just added more noise. All of a sudden, you didn't just have a PR with 5,000 lines, God forbid, but you also had an additional 15 comments, 9 of which made no sense whatsoever, and 4 of which were, I guess, in the ballpark, and then there was 1 that was maybe worth looking at. So it didn't actually help the problem, made it worse.
Mhm.
What has changed is better models and better strategies for using these models. So the way we, in our platform to our customers, but also ourselves now, use automated code review is essentially as a risk ladder. So we're at this point auto approving pull requests. And that has been the real unlock to bringing the number of pull requests down significantly. Meaning that the code that gets produced gets reviewed for what is the risk of this change? What is the risk of it breaking production? What is the risk of it introducing security bugs? So, for example, the moment it touches any authentication and authorization code, it is escalated to human review. There's just no way you're going to get that through. There's a limit on number of lines that he can push, which has gracefully brought the number of lines in a pull request down. Because, engineers optimize for throughput. So you optimize for smaller reviewable units. If you touch the database, it's manually reviewed, etc. So there's a risk appetite. There's essentially a risk budget that we define and that we have the agent review as. And only if we're well within that risk tolerance does the thing get auto approved. Turns out most of the PRs actually are well within their risk tolerance.
Okay.
Most of
So
them.
how do you create this assessment, and how do you implement this assessment, risk assessment?
So the key challenge to implementing this, and we're SOC 2 compliant, mind you, right? Like this is all is compliant too. The key challenge to implementing this is essentially the trust in the process, right? How do you know the thing is doing the right thing?
Yeah.
And we have found a staggered approach across 3 dimensions to be helpful. One is the permission to essentially have your PRs auto-reviewed and auto-merged is an earned right. Not everyone has it from day one. Not everyone writes the same amount of the same quality of code. It is an earned right. And trust takes the stairs up and the elevator down. So if you break production, it is still you as the author, it's still your responsibility. The code is still your responsibility. So if you break production, if you do something stupid, you just lost that right. Thank you. And you have to earn it back. So that's one. The rollout is not uniform across all engineers. It is a staged rollout. The second goes for this risk ladder. We've undergone several iterations until we reached the set of criteria that we employ today, and we keep iterating on it. And we started very, very conservative, very conservative. And only over time did we extend the permissions of what that thing could auto approve. And the
Okay.
third,
So What you're what you're describing is super important because I'm getting a lot of questions from CTOs and head of engineering about governance. So what you're describing is essentially that governance.
Absolutely.
And so, can you elaborate a bit more about your approach to the risk assessment? You said, okay, you were very conservative. Can you give us an example of or walk you through your mental model about how you look at risks and what were some of the first policies that you put in place and how you elaborate on those?
Yeah. There are two dimensions that we used as guiding dimensions. One is, what are the many small changes, the toil that we know is low risk but still happens. It's things like adding a test case to a unit test, not removing one, not changing one, adding one. It is documentation. It is typos on the front end, small styling changes. Like there are classes of changes that are known benign, and so you
Okay.
can very explicitly allow list them and go, okay, so if it's this change, then you're allowed to go through. And over time, you can expand the set of what's allowed. And eventually, you'll get to a point, or might get to a point where you go, okay, we're going to flip this around and we're going to deny certain things. So there's this sort of natural evolution. The second dimension is we have a set of engineering principles by which we write our code. And the first principle is consistency. We value consistency over individual choice. That's not to say that individuals shouldn't, do their best work, but it is to say that the conversation of, I think variables are named to be with an underscore, or camel case just isn't a conversation. We've decided we're going to do camel case, everyone does camel case. And the thing that also, for obviously higher value constructs, the thing that LLMs are really, really good at is generalizing patterns within their context window. They're excellent at that. They're also really good at detecting when things fall outside of this pattern. And so we've instructed our agents to pay close attention to consistency with existing code base. So we're essentially using the existing code base as guidance for what's an acceptable change and what isn't. The last thing I'll say, the third thing, what's really made a difference is that the agent can actually run and interact with the code. It doesn't just look at it. It actually interacts with it. It runs the unit tests. It verifies the coverage. It can write a new unit test and go, okay, no, this test isn't needed, or it is needed. That, combined with a multi-step instruction set. So this isn't one fat prompt that gets thrown at a pull request, but it is one agent that does something. There's another agent that does something, and then there's another agent that does something, and some of them might share context and some of them don't. So you have this sort of rich environment in which the agent can work, and it's not just I looked at the diff and I guess it works.
Okay. Okay. So basically, you have your agents that are working together to do reviews. It's not just one agent that is doing a review. It's a swarm of agents that are working together or not, but they have specific tasks and looking at the different aspects of what you want. So running some tests and making sure the code is aligned with your conventions that you have defined and so on.
And also a meta reflection. So it is essentially, some of it is multiple instructions to the same agent. And so it is, for example, verify that there are no changes to RBAC. I'm making this up, right? Like, it would be more precise, but roughly that. And then it goes, okay, I'm checking these in those files. I guess there are no changes. And then the second step is verify your verification, essentially. So you can layer sort of this meta reflection into the review process with a very explicit failure mode. So part of what automation, so the part of our product in which we've implemented that can do, is it at the end has a built-in meta reflection part where it goes, okay, this didn't work. We're going to call this failed. And so you also get, like, a key challenge to any form of automation is, how do you make sure that the automation itself works? How do you ensure that that doesn't break? I mean, we've all been running CI systems for decades now. We know this very well. And agents are no different. So in order for this review process to work, you need to be sure that you essentially exit early. When you're not certain, you leave the process. But then you also get the data that tells you this is what's happening. right? We are continuously missing the mark on what we're looking to review. Especially, your engineers very quickly will come to rely on these auto reviews, and they'll get, let's say, frustrated if they don't happen, because you're ruining their day, right? Like the whole point is you want to get a change across, you want to get a change in, and you'll
For
be
sure.
measured by this too. Like we can claim, like we all know that a metric that becomes a goal ceases to be a good metric, and yet we do it every time. And so very quickly organizations succumb to the idea of measuring the number of pull requests and the amount of tokens, and all the easy things that are there to be measured. And obviously, engineers then will want to maximize
For
these.
sure. As always. Okay, cool. Good. So we talked about having. One thing that I wanted to dive deeper on is you described the fact that you have agents that are doing some reviews, and agents are not deterministic. We know that, or LLMs are not. So, but we do expect consistency and making sure that our agents are not taking any shortcuts because it's easier that way, or because that test we have all seen that they modified the test because they said, "Oh yeah, the test is failing, so I'm going to change the test." No, you want to test it. So, how do you what have you put in place to make sure that the agent is going through a very deterministic workflow that you have defined?
So we've been working with non-determinism in the SDLC for the longest time because humans too are very non-deterministic. I hear that objection quite often. Well, agents aren't deterministic. Well, so are humans. Review processes have been broken forever, really.
Forever. Yeah.
Agents, I would argue, are actually better at at consistently upholding certain standards. When instructed well, they'll do a better job. Like a review agent is going to catch the removed test case more likely than Bob, who just came back from lunch at 1 o'clock, really has a hangover because he took the extra pudding and isn't, his friend across the desk just, hey, can you just rubber stamp this, please? I need to get this in, right?
Okay.
The agent is going to be more relentless here. And in fact, this is what we find. We found our quality to go up, down.
Okay.
Our mean time to recovery has gone down. Our change failure rate has gone down. And it is exactly because we have better reviews and we can uphold our standards more. Now, the irony in this is that the incidence of something slipping is low and hence unlikely to be caught. We still mandate that humans are responsible for a change. It's the author who's responsible for the change. So if you merge something, it is your name that's attached to it. You no longer have the excuse, yeah, but Bob reviewed it. I don't care. There is no
Maybe.
Bob,
Yeah.
right? It is on you to get this change through. And so what we've also found is, for example, the test case example, because we incentivize smaller PRs, that has actually become more tenable. And it's made it more likely that that authors actually review the code that the agent has written. In our product also, we have a built-in review functionality that lets you review code and then mass submit many comments at once so that the agent can go away for half an hour, do its thing, and you can do something else. So there are sort of multi-layers to making this work. It's incentivizing human behavior correctly. It's instructing agents correctly and also embracing the fact that they're better at upholding standards. And it is giving the right tools that mean that as an author, you can drive high quality changes.
Good. Okay. So we have been talking about reviews, and because that's one of the bottleneck that most people are facing now since they are using multiple agents. So, what is the next step, or how background agents come into the picture?
Yeah. The next step is automating the toil that we all hate doing. That's a simple version. And I mean, we as an industry, we've been on this journey for a long time, right? Like Dependabot and the likes have been a good foray in that direction. And now we can finally do, for example, dependency updates that go beyond just, hey, I bumped the version, now half your API is broken. but we can actually meaningfully correct those changes, and that's where we see a lot of uptake, is that kind of automation on the things that most engineers don't like doing. CVE mitigations are a good example of that too. So many CVE mitigations essentially boil down to updating a library, right? It's updating a dependency. And so being able to roll that out at scale is very, very helpful, or even have that done automatically. Code review is a form of background agents, a very important one. But also an entire class of observing production. So when we look at this simple SDLC model that I outlined earlier, plan, implement, review, deploy, operate, there's an arrow that goes from operate to plan, right? We observe something in production and we go, hey, our error rate goes up on this. Let's go and investigate and fix it. Now, there's no reason that should be a human. So you can absolutely, in fact, we have several agents in operation, as do our customers, that observe the production system, scan through logs, observe metrics. And if something changes, go and understand why. In the worst case, file a ticket. In the best case, open a PR. And then if you've automated the rest, the PR automatically lands and does the right thing. Now, how do you observe this is a fun question.
So do you have do you have integration with observability tools and hotel? And,
We do. So we integrate with Grafana, and you can use the AWS tooling to do CloudWatch queries and understand what's happening. We integrate with Sentry, which we use ourselves, where we pull error logs. At the end of the day, MCP obviously is the unifying factor, and then having good centralized authentication primitives that actually make this secure lets you integrate with pretty much any system. The question is, how do you know that what you're merging is the right stuff? And here too, background agents are very helpful, because all of a sudden you can have summaries that go through your repo. I, for example, have a daily summary in my Slack that just tells me, hey, this is what we merged, and here's where we're making changes, and this is an area of focus right now. That's insanely helpful.
And how? So another slob or effect of using agents is the fact that many people are reporting that keeping the architecture under control is very difficult, because you may have your initial idea and components that you want to use, and then you let the agents run off, and they work and they produce this, and then they say, okay, I need this, I need that, and then that, and then your architecture that you had in your mind is something very different, and it's a kind of a monster that you end up with. So how do you what are some of the strategies that you come up with to address this?
Yeah. And this is where I think we'll be operating, at least for some time, in a mix of that stage 2, stage 3 model, right? Like where you have some degree of automation that automates away the toil, and where you have humans that very directly drive a change. And the convergence of an architecture in a particular direction, at this point, I would say to a great extent, is still a human endeavor. So if we make greater architectural changes, we have an architecture council where we debate this, and we have someone who is responsible for driving this and then distributing that also through the organization. That's the classic way of working. That has not necessarily changed. What has changed is the acceleration, the speed with which that happens. So the design doc now was produced by an agent. A human did not type those characters. The implementation of it is produced by an agent. It is not something that a human does. And with the likes of sub-agents and the ability to spin this out in parallel, you can now drive changes at a scale that before would have taken weeks in a matter of days. So the acceleration is significant, but at the end of the day, it's still a human endeavor. Like one thing that I found very interesting is when AlphaGo won Go, that doesn't mean that we all stopped playing Go. I mean, some did famously, but we all, like as humanity, we did not. And it turns out we don't care about playing Go. We care about humans playing Go. And the same is true for software. Like software is predominantly an economic endeavor, yet we care about humans writing software. And that is still true. So much of that translation of business outcomes into code doesn't just happen in meetings. It also happens in the kitchen, and it also happens over lunch, and it also happens at that conference that you were and your agent wasn't. There is still a deeply human element to the production of software, and that I don't see go away in the near future.
Yeah, agents are just tools that are super powerful, but human must stay in control and driving
Exactly.
this. Good. The I think I'm still struggling with the question I asked earlier about how to stay productive when you have basically agents running in parallel.
Yes.
I think we can put the guardrails, we can put everything in place so we can trust the agents, kind of trust the agent to do what we expect. But still, it's the cognitive load is quite important for developers, as we run multiple things in parallel. So, what have you seen working? I mean, I think you said in the Corey Quinn discussion that you had that it's like running 5 slot machines at once, and I really like that because already when you go to Vegas and you see people, being super hyper focused on one machine, they are really, really into it. But now think about being covering five of them. It sounds impossible for the human mind. So, how do you approach this?
Yeah. So indeed, humans, we're not necessarily built for multitasking. We're not built to do too many things at the same time. And the cost isn't so much holding, like there's a limit to how many things we can hold in our minds at the same time. But the cost isn't so much that number. The cost is needing to switch between them. So if I
Yeah.
need to switch every 2 minutes, that's just not going to work. And what that means for agents is if you plot sort of productivity over time between disengagements, like the time between the agent disengaging and asking you something, there is essentially a very sharp dip and a valley of pain, if you so like. So if the agent comes back to me every 30 seconds, then I just do one thing essentially. And 30 seconds already painful enough if you consider that an iterative process. So that would need to be much shorter than that. And then several minutes, like I'm not going to meaningfully switch between agents every 5 minutes, right? Like I'm probably going to go off and read Twitter or something. Um, However, if
Now
ag-
X.
go on, sorry.
Now X. Sorry.
Now X, excuse me.
No, no worries.
Trying my age here.
We still,
Um,
still, yeah.
so if it runs for half an hour though, or for 15 minutes, then you can meaningfully context switch and you can meaningfully do things in between, right? So one is, how can an agent do work for long enough so that you don't have to constantly go back there? And we have seen meaningful improvements on this time between disengagements in the last year. Part of it has been the models. Part of it has been the way we drive these agents. So spec mode has been a key, or plan mode has been a key piece. Now/goal, well, the thing that Codex pioneered and Anthropic has retrofitted, but also like Ralph Loop that came before, commenting within a platform and sending all these comments off at once instead of going like, do this, wait for 3 seconds, do this. But there have been several sort of innovations in this space that mean we're now seeing longer time between disengagement. The second thing is you need an interface that removes this cognitive load. You need an interface that is carefully designed to let you do multiple things in parallel and minimizes the state you need to hold in your head. Ideally, not, okay, it's in this directory, there is this version of the branch, and there is this comment that I sent last. If you need to remember all that, your host. What you need is a platform that might even make it so that when you come back to a conversation, you can very quickly restore the state of like, okay, this is what we're working on. This is what I sent last. This is the state of the world. With all these things combined, not only does it become possible to do many things, but it becomes actually pleasant. Like there is flow state to be found in parallelism.
Okay, cool. So yeah, and that goes back to the qualities of background agents as you described. The fact that you give them all the rights they need to be able to operate within a contained environment. So it's under control. So you don't need to review the permissions all the time, and you can let them wander, and they can work together to achieve the goal that you set. And that takes a while. Okay.
Exactly. It is really a quality of the platform that you're using. And here, like, it's immediately obvious how needing to approve everything completely means that any parallelism is out of the window, right? But that's just not happening.
Yeah. Yeah. True. So there are a lot of debates about the future of IDEs because I mean, many of us we went back to the CLI to the terminal because this is where Claude Code and Codex CLI and Kiro CLI and others are operating, or Pi. So now people say, I don't need an IDE anymore. I don't need my JetBrains or my VS Code anymore. So what's your take on this, and how do you foresee that?
So the terminal is a good choice for these early days, right? Like where we're still exploring the ergonomics and the form factor. The terminal is great because it lets us move really, really fast. And also when you look at, the spear of the adoption, or the tip of the adoption curve, it's typically folks who are more sort of savvy and who want to faff with things and who live in the terminal. So it would make a lot of sense that we would start there. We do see a trend away from the terminal and back into IDE or IDE-like systems. Case in point is that even very early, Codex and Claude Code had integrations into IDEs. You can run them within IDEs. There is arguably still a need to every once in a while go and look at a file, and what do you use for that? It's VS Code. So the role of these editors then changes, and they get more closely integrated with agents. We also see, for example, if you look at Codex, like the Codex desktop app is fantastic, and it does a lot of the things that previously you would have used an IDE for. You look at a diff, you need a terminal. The same is true in Ona. We've started with giving you VS Code there in the web right next to your agent, and we've since bit by bit transitioned into a world where you have a terminal and where you see your changes, and some of the functionality that you would have previously used an IDE for now becomes part of the main surface. And I think that's going to continue. Um, Half a year ago, folks heralded the end of the IDE. That may or may not be true. I think what's going to happen is we might call it something else, but the integrated development environment, the thing that combines the things you need, the surface that combines the things you need to write code will not go away. It's going to change face. It's going to look different, but it's not going to go away. And so here's spicy hot take: terminals, agents, also their days are numbered.
Yeah, I can see that as well. Cool. Thank you. Any closing remarks on the background agents?
So background agents are a reality that significantly accelerates engineering organizations, not just the Silicon Valley startups, but large regulated organizations.
Mhm.
And I don't think this is being heard widely enough yet. Right? There's some early interest, and the leaders of these organizations see it, and it will take a while for this to diffuse throughout the entire organization. But it is a reality, and it is a reality for some of these firms already. We've been hearing this for so long. It's not AI that's going to take your job; it's the person who's using AI that's going to take your job. And the same is true for large organizations. So I actually do want to stoke a bit of FOMO here. There are people who are meaningfully accelerating their development organizations by using background agents today. So if you're not doing that, if you're right now rolling out Copilot, believing you're riding the wave of AI, I'm sorry, but you're riding the tail end.
Yeah,
You really want to be looking at how you can meaningfully automate your SDLC today, because there are organizations who are doing that.
correct. Cool. Thank you. I have a few questions to end this. Would you have a book to recommend? Something that you found really good? that you would offer that to everyone?
So I generally enjoyed the Phoenix project and the Unicorn project, and they're a bit
Yes.
dated. I think we've all read them. There is one in the same vein of manufacturing that I found interesting, which is called The Origins of Efficiency. And it goes into great detail on how, through driving efficiency in manufacturing processes, we've heralded unknown comforts for everyone. And I do see a lot of similarity in manufacturing and software.
Yeah.
So this
Agile.
very timely.
Definitely. What's your favorite dev tools that you have discovered lately besides Ona?
This is a tricky one. I'm so at home in Ona that I'm not spending too much time looking around, to be honest.
Okay.
It's a tough thing to say, but I don't have a really good answer for you here.
Okay.
One thing that
No
I will
worries.
say that I've become a bit enamored with lately is local models, more out of curiosity, like just curious where that's going, and I am amazed at the strides we've made in making that accessible. You can literally download LLM Studio or Ollama and run a very powerful model on your M5. That I actually was quite amazed with, especially if you compare that to just a year ago, where you had to deal with Python and all that fun stuff. So, I know that counts, but I do live and breathe all my work in Ona.
That's good. That's perfect. I'm also looking deep into the local model as well. I think I'm really impressed by MLX and what you can get out of an M5 with an M4 CPU. So really cool. What are you going to learn and dive deeper on next?
Rust.
Rust. Okay.
It's been a long time since I've learned a programming language. Too long a time. And I'm very curious now, with having this very powerful, knowledgeable tutor by my side and trainer by my side, how does it feel now to learn a programming language? So for no better reason than curiosity, I'll try and teach myself Rust.
I'm doing the same with Swift at the moment. So it's interesting because I wanted to explore more the MLX side of things. And final question, what other developer should I interview next? Who should I have on the show? Who would you recommend?
Ooh. There's a bit of publicity bias, but I think Peter Steinberger's take would be quite interesting. Obviously hard to get a hold of, but
Yes.
um, and not so much for his work around OpenClaw, but really for his perspective on how these more unbounded loops, like really the innovation of OpenClaw was to pull out all the stops, right?
Yeah.
And to have these long running loops, which have now found their ways into common agentic harnesses, famously codexes/goal.
Mhm.
So I'd be very curious on his take on where he sees automation and software engineering going with these like long running loops. We we have a self-built code, like self-running code, self-driving code base. We ported Xterm.js to Go. No one's ever touched that code. We've not, and we're using it in production. It sounds scary, but it works surprisingly well. Like there's conformance tests that test minute details, and this has been run in such a loop in background agents. And I'm curious where this is going. Where do we see sort of the next level of automation going?
Perfect. Great. Wow. Uh, Very inspiring. Thanks a lot, Chris, for your time. And I will definitely spend more time on the background agents moving forward. Thanks a lot and have a great day.
Yeah, really enjoyed the conversation. Thank you.
Thank you. Cheers.